Hello and welcome back to Polytoots. In today's lesson we're taking another look at a ocean shader using shader graph. I say another look only because I've done like 2 of these before, but there's been a lot of improvements to shader graph since the last time I touched it, which is probably like nearly a year or so ago, not that anyone cares. So we do have some refraction happening here. There's a texture-based displacement, we've got some normals. It is the same idea of just 2 textures panning in opposite directions for those of you who are familiar with this technique. But when you are using proper height and normals, it looks a bit more convincing. I should specify this is a good base for a water. I do advise that you improve upon it, but for the sake of this tutorial, we're going to try to keep things simple, try to keep it under like an hour long of just me rambling. So if you like what you see and you want to learn how to do it, then we can just go ahead and start that. I will just mention quickly though that the Walrus cave that you see here is not going to be available for download on my Patreon, but it is freely available on Sketchfab. And this time I've got the model from a user called Rosie Jarvis. She's got a lot of cool hand-painted stuff. I recommend checking out her work and giving the account a follow. And I will be providing a link in the description for this specific model if you just wanted to check it out. So on to the actual tutorial. I'm just going to start by creating a new blank material, and I'll just put that on my plane just so we're starting with a clean slate. And before we begin any shader stuff, I just want to mention that for this whole thing to work, you do need to change your pipeline settings. So if you come down into the folder here called settings, and then you'll have the 3 quality settings. So make sure you select whichever one you are outputting to. By default, I think it's the high quality one, or you can just go ahead and change all 3. But either way, the important thing here is that you enable the depth texture and opaque texture. If you don't do this, things are going to get pretty screwy. It's a common mistake because even if you don't tick the depth texture, everything will look fine in your scene view, but your game view will be completely wrong. I know it takes me forever to actually just get to the tutorial, but there is another slightly important thing to mention here. At the moment, shader graph does not support tessellation. And since we want to be doing a texture-based tessellation, we need to supply the geometry ourselves. So I'm just going to be including a subdivided plane for this. In the future, I imagine we won't need to do this, or if you're using Amplify Shader Editor that has tessellation working, but for some strange reason, shader graph is not supported. I'm not sure about HDRP, but for URP, it's a no-go. So we'll just use this for now. So let's create ourselves a shader, and we'll be using a PBR graph. Call that whatever you want and open it up. And the first thing that we're going to work on will be the refraction. And the way that we're going to be doing this is by using something called a grab pass, which essentially just takes a picture of your screen. And then we're going to distort that texture based on a normal map. So we're going to put down a sample texture 2D here. And we're going to create a property of a texture 2D and we'll call it normal map. And then we'll just drag that in and hook it up. And make sure you set the type here to a normal, which reminds me actually, for the normal map itself, by default it will import into Unity as a default texture type. So just make sure to change it over to normal map, that way Unity knows to read it as a normal map. But anyway, back to the shader. We're going to want to combine the red and green channels of this. It will probably still work if you use RGBA, but the alpha component of this texture has nothing in it, and the blue channel of a normal map is essentially the flat channel, so it doesn't contain any information that we want. At least that's my understanding. So yeah, we'll combine red and green, and then we'll get ourselves a multiply. And make sure you only use the RG2 slot here, because we are only putting 2 things into this node, so there's no point in us outputting, you know, a 4 or a 3 channel. We only need the 2 channel. And then we'll just create a vector 1, and this will be the refract strength. And so that's what we're going to put into the B slot of our multiply. So now we have something that will essentially control the power of our normal map. But of course that by itself isn't going to do anything. We need to create something for this normal map to affect. So we're going to grab ourselves a screen position node. And then again, we'll split this on the R and G channels and combine it again with R and G and output only on the 2 slot. And then we'll just add it all together and add a scene color node onto the end of this. That's pretty much the refraction done. So we can hook this into the albedo slot now and just have a look at what's happening here. Obviously we need to change over our material so that it's using the actual shader that we are making. And by default, every shader you create with shader graph goes into the shader graph directory, which is kind of lame. If anybody knows how to create your own directory, then please let me know. But either way, we'll put on our shader and we'll throw in our normal map. And now you might notice that things are getting a little bit wonky here, and that's because we need to change over our PBR master node here to a transparent workflow. So that's a tiny mistake on my part. I promise there's only like 3 or 4 more mistakes in this. You can see with the normal map on, we have a refract strength of 0, so nothing's really changed. We can see through it, which is a good sign, but if you start to change the refract strength, you can see that it is distorting our texture based on the normal map that we have. So if you're using a different normal map, it will refract in a different way. So since we're done with the refraction part of this, I'll just select all of the nodes and hit Ctrl-G on the keyboard to group these together. I don't know where else you would hit Ctrl-G. I'm not sure why I have to specify on the keyboard, but you know, I'm just speaking here and words are falling out of my mouth without me thinking. Before I move on, I do just want to mention that there is potentially a better way or a more accurate way to do this refraction. And this is from a website called CodinBlack. And in his example, he uses a custom function and a tiny bit of code. And so I've built that same thing using the normal map texture 2D, which influences the index of refraction. I will be including this node setup in this shader graph, but for the sake of the tutorial, I'm not going to cover it. It's all on CodinBlack.com, which I recommend checking out anyway. The guy seems to have like a lot of cool tutorials there. As I say, I will just be using my simple refraction here, which seems to do the same thing, at least in my inexperienced eyes, but I imagine that the other node setup is probably handling things in a better way. Moving on though, currently our refraction is working across the entire canvas, and I want to mask that out by something, and the thing that I want to mask it out by is depth. Meaning if there's an object underneath the surface of this water, if it's close to the surface, then it will be refracted. Whereas if it's, you know, quite far underneath the water, then I have no need to refract it. And the way that we're going to calculate the depth here is with a scene depth node, which, as you can imagine, gets the depth of the scene. And we want to do this based on the camera, so we're going to multiply this with the camera node and use the far plane option. And then we're going to subtract this by a screen position node. And make sure you set the mode to raw. And we do only want the alpha of this, so we need to throw in another split node and then grab the alpha, and that's what goes into our subtract. Lastly, we will just throw on a saturate node at the end of this because we got a lot of things happening, so it's a good time to just clamp these values so they don't go below 0 or over 1. And then we'll just grab all of this and we'll overwrite the albedo that we have now, just so we can see what this looks like. And so you can see that our depth is being calculated here, and it's appearing as this sort of black gradient, essentially, which is fine, but for masks, typically it's the white value that lets something through, and it's the black value that does not. So we want to come back to our shader here and throw in a 1- so that our mask is inverted, and then we can start to do something with it. You know, we can use the white to let the refraction through, and the black will not. The other thing that we could do here is, at the moment, we can't control this at all. You know, we can't control its strength, we can't control its size. So we'll just throw in a couple of multiplies and some vector 1s. The first one comes after our initial split here. So the split from the screen position, we want to multiply this by a vector 1. So we'll make that a property, and we'll call this the depth distance. So this will control the actual distance of the depth itself. And just replace that with the node that was there before. So now instead of the split going into subtract, we have split into multiply with our vector, and that goes into subtract. And then we'll just throw in one more at the end here, but before our saturation node. And this will just be the overall strengths. So, you know, if you can imagine, because this is at the end of this node setup here, this property controls, you know, the overall power of everything that's come before it. So it doesn't matter what we've done before. This is kind of like the master power node, like the master volume on some sort of game that you're playing. You know, you can tweak all of the little sound effects and whatnot, but ultimately there is a master controller, and this is that. So once that's in, we can just give it a quick look and see what's happening. And I'll be honest, I'm a little bit confused as to the way that the values work here, in that for the depth distance to even come into effect, it has to be, you know, like about 0.9. Maybe this needs a remap or something, but it works, so I'm happy with that. I'm just a bit confused by the actual numerical inputs that we have to do. But my confusion aside, it works. You know, we can control the depth and we can control the overall strength of it. And you'll notice that as you rotate the camera around, that does change how this looks. I believe this is even the same with the Amplify version, but something about this, it seems like it's moving, or not moving, it seems like it's changing too much, but could be Could be me. I will be building an updated Amplify ocean after this. It's going to be not the same. It's going to be using something pretty cool. So I guess at that point I'll see if this depth stuff behaves the same. Maybe it's a Unity thing rather than a strictly shader graph thing, but we'll find out soon enough. I've been rambling on for a little bit too much about that. So let's just go back to the shader now. Once more, since we're done with this, we'll select everything, Control G, and give this group a name. And so now that we have this set up, we need a way to combine this depth with our refraction, because remember, we want to use this as a mask to show what is being refracted and what isn't. And the easiest way to do that is with a lerp. And the cool thing about lerps is it is just an A and a B slot and then a mask. And the mask, you know, it's just a black and white value, and it defines, you know, what shows in A and what shows in B. So we'll use our depth as our mask, and then we'll throw our refraction into the B slot, and we'll leave the A slot blank for now, which means, you know, what will be black will stay black, but what will be white will allow our refraction node to come through. So quite simple, just hook it all in and we can just go and see what that looks like. Seems to be working okay, and of course we have our controls for the depth, so we can control how deep this refraction will go and the overall power of it. So pretty cool stuff. Now that that's all out of the way, I think it's time to actually make our water look a bit more like water. So we're going to move on to the normals next, which means we're going to start by just placing down a sample texture 2D, and we already have the normal map as a property, and that's what we'll be using, obviously. Now make sure you do set the type here to normal. I forgot to do it at this point, but I will remember to do that later, but you can do it now if you want, and then you can say that you are better than I am. But then after you've changed your type to normal, you can add in a normal strength node. I find it's always good to use one of these when you're doing oceans and various water bits and whatnot, because, you know, it's nice to be able to tweak your normal map. Just keep in mind that you usually only want to reduce the power of your normal map. You never really want to increase it because you can't add detail to your texture. And so to control that, we'll just create a vector 1, call it normal strength, and this one we can actually turn into a slider, since, you know we only want a 0 to 1 range. You know, you don't want to go below 0 on your normal map strength, and you don't really want to go above 1. And now, if you remember at the beginning of this tutorial, I was talking about how this is the dual panning, like the opposite panning technique. So for this, we're going to need to create some UVs of our own where the texture is actually scrolling. So to do that in shader graph, we create a time node, and we're going to multiply this by a vector 2. And the reason we're using a vector 2 in this instance is we want to be able to control the X and the Y independently, because we're dealing with an offset here. So you can, if you want, use a vector 1. It means it will scroll X and Y at the same value that you put it in. But I prefer to do a vector 2, so I can either have, you know, my X be blank, or just a small value in X and a high value in Y. I say high, but I just mean 1, basically, because we're going to multiply this with another property, which we'll call our pan speed. And this ultimately affects the speed, but the vector 2 technically also does control the speed, but we only want to use that to control the direction. So just keep the vector 2 between values of 0 and 1, and then let the pan speed vector do the rest of the work. So once that's done, we can add in a tiling and offset node, hook in all of these nodes into the offset, and throw that in, and we can have a quick look at it. And you can see here how the vector 2 is only controlling the direction. So if you come here and just minus the amount, then it will go in the opposite way. Oh, actually, I think I just mentioned that you should just do a 0 to 1 range. No, sorry, you can absolutely do a minus in the vector 2, because if you want it to go the opposite way, it needs to be an opposite value. Oh, I'm a good teacher. But anyway, while we're here, and while we still have the tiling and offset node, we might as well create ourselves another vector 1, and we'll call this one the normal tiling. So this will control the actual tiling amount of our texture, and we'll just stick that straight into the tiling slot. Pretty handy. Now there's two things that I noticed were wrong here. For starters, my plane has that little corner on the side. That should not be there, and by the time I come to upload this stuff onto my Patreon, which is free, by the way, you don't need to pay to get this stuff, I will have fixed that so it will be completely square, because, you know, you want to be able to tile these planes around without having a weird hole in the corner of it. The other thing I noticed was the normal map being not set to a normal map, so I just fixed that here. And now we are both equally intelligent. On a more important note, however, you'll notice that there are these seams in between these two planes. And that's because we're doing these UVs based on the actual object UVs. You can do world space if you want. I have a tutorial where we do that. But for this, I know the textures are tiling and we're not doing any procedural stuff, so I figured it was just easier to do the object UV space, which means your tiling number needs to be like a round number, like, it has to be 1, 2, 3, 4. I'm sure you know how to count as well as I do. You don't want to do like half values or point things because that's when it will not work. It would be nice if on shader graph you could set a vector 1 to be locked to like an integer range, like with amplify. Pretty sure I said integer, doesn't matter. Maybe in the future they'll do an update, but for now you'll just have to remember not to do a decimal point. You're just, 1, 2, 3, 4. I'm counting again. Jesus, stop it. Okay, back to work. We can just grab these scrolling UVs that we've just made and just slot that straight into the UVs of the refraction stuff that we had done. So now as this normal map moves, so does the refraction of it. And since it's using the same tiling as well, everything is lined up 1 to 1 because it's using the same normal map. It is worth quickly pointing out here that the normal strength property that we've made is still only controlling the strength of the normal map itself and not the refraction, which for me is fine because I don't ever intend this water or any water I make to have a normal strength of 0, so there will always be some amount of refraction happening anyway. But if you wanted to tie it together, then you just have to stick in a normal strength node into the refraction area as well and just use the same vector 1 property that we have for the normals. So sticking with the normal map stuff, we need to create a duplicate of what we already have and then just pan it in the opposite way. So I'm just going to copy over the sample texture 2D and the texture 2D property and also the normal strength. Make sure these are using the same properties that we've already set up because we don't want to create anything new here. Like, it's going to use the same strength property, going to use the same normal map. We're just going to use different UVs. And to create the different UVs, we're just going to copy over all of this panning and tiling stuff that we already have and just paste it above. And so at the moment, it's exactly the same. If we were to just put that into the UVs of our duplicate normal map, it would seem as though we haven't done anything. So the first thing I do is I just hook in the time node that we're already using from the first one, just to get rid of the time node that we've duplicated. I don't know if this makes any difference in code, but I figure less nodes is probably more efficient. And then, of course, make sure you change your vector 2 values because this is going to be the new direction of this panning normal map. So you don't want it to be the same as what we already have because then it's just going to move in the exact same way. You can go with opposite values here if you want. It doesn't really matter so long as they are different. And you can always change it after the fact anyway. So it's just get something in there that is not the same as what you already have. And for the tiling amount, I like to keep it as simple as possible. You could, if you wanted, create a whole new vector 1 to control the tiling amount of this duplicated normal map. But what I prefer to do is just I create a multiply and I feed that vector 1 property of the normal tiling into it, which means I'm still only using one vector 1 property, but whatever the value is, it will be multiplied by an amount for the other normal map. So, it will always be bigger than the original. This is just the way that I do it. If you want, like I say, you can create a whole new vector 1 for this and just, have complete control over how big it is. Same for the speed. I leave the speed alone because technically if this texture is larger or tiling more than the original one, it's going to have the illusion of moving at a different speed anyway. So, that's just me trying to keep my material as simple as possible, but you can obviously do whatever you want. So when you're done with all of that, make sure you use a normal blend. And this will blend the normal maps together correctly. And then you can just see what that looks like. And the effect should be quite immediate and quite obvious. There we are, it's looking pretty okay. I do recommend going back into your shader and, tweaking with the values, like how much you want something to be panning by, how large you want the other normal map to be compared to the original one. Little things like this until you're happy with it, basically. You may have noticed, though, that we're not doing anything additional with the refraction. So we're not duplicating our refraction to make sure that it's, accounting for this normal map that's panning in the opposite way. And for me, this is because the illusion of the refraction is already working. Like, I don't need it to be so accurate that I have to, create another duplicate of my refraction to feed in these new UVs to account for the other normal map that is going in the other way. You can if you want, you're more than free. It's basically the exact same setup that we've just done. But personally, I kind of think that's overkill. But anyway, as usual, now that we're done with both the normals and the panning and tiling UVs, we'll just select all of those, Control G to group them, give them a name, and yeah, we can move on to the next bit, which will be the displacement. And so for this, we are going to use a height texture that I've created. And again, just worth pointing out that all of this is available if you wanted to grab it for free. Just do a hoppity skippity along to my Patreon and it's all there. So we're going to create another texture 2D here, and we'll just call this one displacement. And now instead of creating a sample texture 2D to put this texture into, we need to create a sample texture 2D LOD, because that's the only thing that works with the vertex position offset stuff that we want to do. I don't know why, but you know, it is what it is. Now's a good time to mention though that these aren't just random height and normal images, they were created together, like they're part of the same set, as it were. Like if you were to use a different height with these normals, it would look incorrect, and you know, vice versa. And if you were curious as to how I've acquired these, it's basically just using the ocean modifier in Blender, which I highly recommend checking out. Not just the ocean modifier, I mean Blender in general. If you haven't used it, it's incredibly cool. But anywho, since we know that we are going to be doing the different UV opposite panning thing, we might as well start off with the duplicate now, and we can already feed our UVs into this since we already have it made. And then we'll just add these together and throw in a saturate, because, you know, again, we're combining these two values together, so it's a good idea to clamp them. And of course, we do want to be able to control the strength of this, you know, to determine how high our waves will go. So we'll just create a multiply and get a new vector 1, call this, you know, something like display strength, and just hook that together. And now we need a way to tell Unity, like, you know, which way we want to displace these normals. So we're going to create a position node, make sure the space is set to object, and we're going to split this, but we're going to combine it into a vector 3 with the R and the B channels only, red and blue. And we'll grab that multiply that we had created, and that will go into the Y slot of this vector 3. Essentially what this is doing is we are controlling the power of the Y value only, and in this case Y is going to be, you know, the object's position, which is I suppose the same as the world Y, but either way this is just easier. And I don't know what the hell is going on with my shader graph at this point, but this always seems to happen where after a while anything I group, if I try to move it, it just goes absolutely nuts. But anyway, feed all of this into that position offset, and now we can save this out and have a look, and you know, it's pretty cool. It also helps, I think, ease the apparentness of the fact that we're just panning like two textures in opposite directions, because these waves are almost, you know, hitting each other, and it's creating this nice kind of movement, at least in my opinion. So now the last thing that we need to do is just the color. And it would be good to have the peaks of our waves be a different color to the surface itself. It's almost as though, you know, you want it to be a slightly lighter color because it's a bit thinner than the ocean itself, so more light is able to come through. And for this, we're going to use that same height map that we have, because that already has the perfect values that we can use. You know, it has the white for the highs and the blacks for the lows. So if you remember the logic behind the lerps, that's pretty much the same thing as what we're going to do here. So we'll create a lerp, and we'll feed the saturated version of both of our height maps blended into the alpha slot of this lerp. And so what this lerp is now saying is, you know, if there is something that is white in this texture, display something in the B slot. If there's something black in this texture, display it as the A slot. So we're just going to create two colors, put them in A and B. One's going to be the top color, one's going to be the bottom color. And that is about it. Now we can feed this lerp into the other lerp that we've made, because that's going into our albedo. Because before, you know, we were saying with the refract, the depth mask is allowing the refraction through, but what isn't calculated by the depth mask is just appearing now as black, whereas we want to just say no more black. We're going to feed in our two colors. And then just for a good measure, since we are adding all of these things together, I am going to just put in another saturate node here, just to make sure that, you know, out of all of the things that are combining together here at the end, nothing is going to be blown like outside of the 0 to 1 range. One thing I will just say quickly is I did try to add in that object intersection. Like when an object hits the water, it has some sort of like edge foamy type thing. But I could not get it to work correctly, in that you can see here there's just these horrible outlines appearing on the surface of the ocean. And even though it's using the same surface stuff that we're doing for the refraction, I just could not get this to go away, and it appeared in the game view as well. So in the end, I gave up. I think it's probably either a shader graph issue or a Unity issue. Hopefully at some point this will just be fixed. But yeah, otherwise, unless I'm forgetting something, which is, I mean, completely likely, I think that will just about wrap it up. As usual, if you have any comments, questions, or concerns, you can just keep them to yourself. No, I'm just kidding. It's always nice to hear from you, even when you're telling me that I'm doing things just incredibly wrong, because, you know, we've all got to learn somehow. And I know I've mentioned it a few times already, but I do have a Patreon, and that is where all of the source files for my tutorials will go. So if you wanted this just as a Unity package, of course not including the Walrus cave, then you can just go over there and you can just grab that for free. It will also contain the textures and the shader nodes if you just wanted to rebuild this shader yourself rather than having the final product handed to you. It's up to you, obviously. I will be working on a Amplify shader tutorial for an updated ocean at some point. I don't know if it will be the next tutorial, but it will definitely be a tutorial that is coming along soon. And it's not just going to be a conversion of what we're seeing here. There is some genuinely new things that we're going to be doing there, and should be pretty cool, but I don't want to say too much just in case none of it works out and I can't actually do the tutorial. But we'll see. So far so good. I also just want to give a shout out to my fiance, who probably isn't watching this video, or if she is, she probably hasn't made it this far. She is currently doing a bit of work a long way away from me. So I just wanted to let her know that she is missed, and I'm pretty sure I haven't killed your plants yet. But, you know, there's still time, so pretty sure that's the end of the video. Thank you very much for watching, and a big thank you to my Patreon supporters. Yeah, I will see you all in the next one.